How do F1 suspension hydraulics really work? Imagine a car that can respond instantly to every bump, turn, and change in the track surface. That's what hydraulic systems do in Formula One cars. They are the secret behind the smooth, controlled ride that keeps drivers fast and stable. But how exactly do these hydraulic systems work? Let's break it down. Hydraulics in Formula One suspension operate on a simple idea. Liquids that can't be compressed easily, like oil, create pressure when force is applied. And like air or gases that squish and lose pressure, hydraulic fluids stay consistent. When the suspension moves, the hydraulic fluid is pushed through tiny internal passages inside the dampers. This creates resistance that absorbs the energy from bumps and quick changes in the track surface. The hydraulic dampers are key parts of the suspension. Think of them as energy absorbers. When the wheel hits a bump, the damper's piston moves inside a cylinder filled with hydraulic fluid. As it moves, the fluid flows through small valves or holes inside the damper. This flow creates resistance, which slows down the wheel's movement. When the suspension rebounds, the piston moves back, and the fluid again resists this motion. By adjusting how easily the fluid flows, engineers can control how stiff or soft the suspension feels. These dampers don't work alone. They connect to other parts like rockers, which are shafts that rotate as the wheel moves. The rockers transfer the motion to the hydraulic dampers and twist torsion bars. Torsion bars are long metal rods that twist under load and act like springs. They help control vertical movement and keep the car stable. Anti-roll bars, which are U-shaped bars connecting both wheels, use hydraulic pressure to limit body roll when cornering. All these parts work together to keep the car balanced and responsive. Hydraulics also play a big role in braking. When a driver presses the brake pedal, hydraulic fluid from master cylinders is pushed through brake lines to calipers. This pressure causes the brake pads to clamp onto the discs, slowing the car down. The system can be fine-tuned during a race to balance braking force between the front and rear wheels, helping drivers control their speed precisely. Beyond suspension and brakes, hydraulics control many other systems. Power steering uses hydraulic pressure to make turning easier. The transmission and clutch also relying on hydraulics to shift gears smoothly. The drag reduction system, which opens a flap in the rear wing to reduce drag and increase speed, uses hydraulic actuation. Even the turbo wastegate and engine valves depend on hydraulics to operate efficiently. Hydraulic systems need to be very reliable because failures can cause serious problems during a race. High pressures are used to deliver quick responses, which means parts must be made from strong materials and maintained carefully. Any leak or air bubble can reduce performance or cause a failure. That's why teams spend a lot of time and money ensuring their hydraulic systems are in top shape. Since 2022, regulations have changed. Teams are no longer allowed to use hydraulics for the heave spring, which controls vertical load. But hydraulics are still vital for braking, steering, gear shifting, and other functions. They remain as a core part of how F1 cars handle the demanding conditions of racing. So, next time you see a car cornering smoothly or braking sharply, remember that hydraulic systems are quietly working behind the scenes to make it all possible.